This is the rule for finding the derivative of something. It's sort of like the fast way, or without using the definition. And this is the way that we are going to do the derivative from now on, almost entirely using the power rule and other similar tricks, of which we're going to start talking about today. But anyway, the basic idea is, if I'm asking you about the derivative of 3x to the 5 minus 7x squared plus 4x plus 1, the way that you do this is with the power rule, and that means in each term of this is a bunch of stuff added together. For each one of them, you multiply the exponent down into the front. So it's like this 5 sort of comes down here and multiplies with the 3 and gives you 15. And then you decrease the exponent by 1. So in that first term there would be 15x to the 4. This is really easy if you know what you're doing. Next, negative 7x squared. The 2 comes down, multiplies on the negative 7, makes it negative 14. And then it's just x to the 1, because I decreased the power by 1, so x squared becomes x to the 1, which is just x plus. Anybody remember what happens if it's just an x by itself? Yeah, the x just kind of goes away. Technically, the x turns into a 1, so this becomes 4 times 1. But the way you can think of that is that it just goes away. And then the plus 1, what happens to the plus 1 at the end? Yeah? That really goes away entirely, like it becomes a 0. So this plus 1 just leads to nothing. You could say plus 0 here if you want, but that plus a constant always entirely goes away in the derivative. All right, that's the power rule. I hope everybody is cool with this thing. This means the derivative of this equals this. All right? Great. This is what everybody already knew. This was the last question on the test, was about very basic sort of power rule kind of thing like this. I had 2 more things to say about this, which are not really new rules, but they're just sort of things to keep in mind. Keep in mind, the power rule can also handle square roots. Square roots, and the way that you realize the square roots in terms of the power rule is you can always rewrite a square root as a power. Square roots are the 1/2 power, right? By which, what I mean is the square root of x, that just equals x to the 1/2. They are the same thing. So if you ever see a square root somewhere, you can think of the square root as x to the 1/2. I'm not saying the derivative equals x to the 1/2. I just mean that's what the square root is. It is x to the 1/2. And so if you wanted to do the derivative of the square root x, this would be the same as the derivative of x to the 1/2. And what's the answer of that? You do the power rule. So the 1/2 comes down into the front and becomes a coefficient. Then you get x, and then you decrease the power by 1. It used to say 1/2, then I go subtract 1, it becomes negative 1/2, because 1/2 minus 1 is negative 1/2. All right, so the square root is the same as a 1/2 power. So if you ever see a square root, you should just think of it as a 1/2 power. Notice the way that I wrote this with the d's, whatever. This is an operation, which means I'm going to do the derivative. The derivative of this is the same as the derivative of that, because the square root x is the same as x to the 1/2. And then the answer is this over here. All right. How about, I just got one more. How about derivative of 3 root x plus 2x to the 4 minus 7. All right. This one, the first thing that I see there has a square root in it, but the others are more ordinary. So I would start by rewriting the square root as a 1/2 power. 3x to the 1/2 plus 2x to the 4 minus 7. So I didn't do the derivative yet, which is why I still wrote dx there. All I did in that step was to change the 1/2 power, change the square root to a 1/2 power. Otherwise, I didn't do anything. I did not do the derivative. Now I'm going to actually do the derivative, and you do the power thing. So this now becomes, the 1/2 comes down front, it becomes 3 times 1/2, x to the minus 1/2, plus The next one, 4 times 2 is 8, so that's 8x cubed. And then the minus 7 goes away because it's a constant. So that's what I get. Any thoughts about that? This is the derivative of things involving a square root. All right? Great. Let's try, okay, one other thing. I said I have two things to sort of keep in mind. The first is that square roots are 1/2 powers. The other is that x in denominators can be written as negative exponent. As a negative exponent is what I meant to say. So like, for example, 1 over x to the 5, that's the same as x to the negative 5. That's what x to the negative 5 means. And so if you see x in the denominator to some power, you can often rewrite that as a power of x using a negative exponent. So for example, if I want the derivative of 1 over x to the 8, this is the same as the derivative of x to the negative 8. So I didn't take the derivative in that step. I just rewrote the thing on the inside. And then what is the derivative of x to the negative 8? You do the thing with the power. The negative 8 comes in the front, x, and now I decrease the power by 1. Negative 8 minus 1 is negative 9. You have to be a little careful when you decrease a negative number. It becomes even more negative. So negative 8 decreases by 1 becomes negative 9, right? Sometimes this can be, slightly more complicated. If it was something like 3 over x to the 5, the 3 being a constant on top, you can just sort of do the same thing. Bring the x up, it becomes 3x to the minus 5. And then the derivative of that is negative 15x to the minus 6. All right, so if you have if your fraction has some stuff on the top, then you just bring the bottom up, and what was on the top is still up there. All right, this can be slightly weird if it's like this, 1 over 4x squared. I want to write that by bringing the bottom up and making the exponent negative. You may be tempted to write this, 4x to the minus 2, but this is not correct. Anybody see what's wrong with that? Don't write that. You bring the bottom up and you make the exponent negative. This is not quite right though. Anybody feel something? Something ain't right. Yeah.
Would you have to make the coefficient negative as well?
Yeah, something about the 4 is what's not right about this. Actually, moving the x squared up and making it x to the minus 2 is fine. But this 4, it's actually 4 in the denominator. It's not just multiplying by 4. In fact, it's actually multiplying by 1/4 because the 4 is in the denominator. So the proper way to do this is, you could write it like that, 4 to the minus 1, because you brought the 4 up also, although I would suggest that's a little, I would rather write it like this, 1/4 x to the minus 2, all right? Don't try to bring the 4 up, because actually it doesn't matter that the 4 is down there. The 1/4 just becomes a coefficient, and everything's fine now. Now we can proceed with doing the usual power rule thing, which is to do negative 2 times 1/4 x to the minus 3, all right? So, all of this to say, don't try to bring this constant up also. It has to stay as a constant, but in the denominator. So you got to keep it as a 1/4, like in this example, all right? And this, I think, is all I had to say. Sorry, I had one more interesting sort of complication of this, and then I have some for you all to try, just to make sure everybody is staying with it. 3x plus 1 over 5x squared. All right, this one is a little more complicated because of the stuff on top. 3x plus 1 on top. Maybe I'll just say at this point, you may be tempted to just take the derivative in the top and also take the derivative in the bottom. Can't you do that? This is a fraction here. Can't I just do the derivative on top and also do the derivative on the bottom? And my answer is, you can do that like it's a free country, but that's the wrong answer. The derivative doesn't work that way. You cannot, if you see a fraction, you cannot just take the derivative on the top and also take the derivative on the bottom. Why doesn't it work that way? I would say, why would you think it works that way? It just doesn't. The derivative is a complicated thing, and it is true that if you have a bunch of stuff added together, for instance, you can do the derivative of each thing when they're added together. But this is kind of a magical property of addition with respect to the derivative. And the same is not true for fractions, and it's also not true for multiplication. So when you see something like this, do not just take the derivative on the top and also the derivative on the bottom. You have to do some work to somehow change this into a format where you actually are able to do the derivative. And the way to do this is to bring up the denominator like we did in those other examples. So the 5x squared, the x squared is going to come up and become x to the minus 2 power. And the 5 is going to become a 1/5. And then I still have the numerator. The proper way to do this is like this. All right. So this is very much like the previous example, although it has a more complicated thing on the top. And so when you bring this other stuff up, that more complicated stuff has to stay like it is. All right? And I hope that you put the parentheses here because my next step is going to be to distribute this. All right? I still don't like this in terms of taking the derivative because I have two things multiplied together. But you can change it into two things added together if you distribute this guy. So I'm going to do distributing like this, right? And so, still haven't taken the derivative. I'm just rewriting the stuff on the inside. It's going to be 3x times 1/5 x to the minus 2, right? You can multiply the constants together. 3 and the 1/5 becomes 3/5. And then what about the x's? I have x and also x to the minus 2. What do you get when you multiply those? Anybody remember how to do that?
Yeah. You add them, so it would be like -1.
Yeah, you add the exponents in this case. So this is like an x to the 1, and I am multiplying by x to the minus 2. So I add the exponents. 1 minus 2 is -1. Great. And then distribute. So that was distributing the first one, this guy. And then distribute the second one is just times 1, so you get the same thing. So this is plus 1/5 x to the minus 2, like that. All right. And now it is in a convenient format to do the derivative, right? Because now it's just some stuff added together with powers of x. So now we can actually do the derivative. I've been writing this d thing every time because I didn't do the derivative yet. But this is the step at which we actually do it. And we get -1 times 3/5 x to the minus 2. That's what happens with the first one. The exponent comes to the front, and then you decrease the exponent. And then plus, same thing, -2 times 1/5 x to the -3 now. And this is my answer. Yeah.
Because we don't use calculators, is that like a sufficient answer?
Yeah, because you're not using calculators, you may in other times of life feel some kind of compulsion to simplify the fraction, but I don't care about any of that. So, I mean, this you could simplify a little bit if you wanted to. You could say this is -3/5 and this is -2/5, but I don't so much care. If your job in this problem is to take the derivative, this is the derivative. It's not simplified, but that's all right. All right. In general, on our tests and whatever, I am not going to expect you to simplify everything at the end, unless you have some reason to simplify it. All right. Okay, I got some like that for you all to try. So in each case, find the derivative. I'll write the derivative here. Derivative of, this work. First one is very simple. I mean, it's like the kind that you should have been able to do before today. I don't know if you can tell, my handwriting is silky smooth today. It's because I laid down that cash and got a real Apple Pencil. I don't like at all how you have to charge it. You gotta pull this little thing off and then stick this in the iPad. I don't like it. You can't use it while it's charging, and you can't charge the iPad while it's charging because it's in the hole. And you can't plug this into the wall because it's the wrong end. It's the wrong end. You can't plug a wire into it. and it comes with a little adapter, this tiny little thing, so that you can plug it into the wall. But then you can't use it while it's plugged in. I don't know. Okay, one last one. I'll write it over here. Other than that, it's great. All right, see what you think. I will give you a few moments. Feel free to talk to your friends about it. It's very similar to one that I did a few months ago. When it's in the bottom, you turn it into, in this case, you can move the x up and make it x to the minus 2.
So 5/7.
Yeah, you keep the 5/7 in front. And then x to the minus 2. And now this, so you didn't do the derivative, that's just the same as this, but now you can do the derivative. This x? It becomes 1.
Oh, okay.
So, right. Yes. All right. So this, the derivative is that. Yeah. This, you rewrote root x. Root x equals x. How you guys doing? Can I say something about this? This is okay. Yeah. Okay. All right. Which one? The bottom one? Oh, just that. Yeah, yeah, right. This. That's right. X turns into yeah. And this. All right. Yeah, 2 times half.
3 I got or half x.
Oh, it's 2,
-3. Negative.
Okay.
So.
Mm-hmm.
Get that. Basically just part of here. Across the top. If I bring this up, it's 5 times 7. I got 30.
It was x.
And then, right.
And then the.
I did it down
If you do the derivative, it's just x, it turns into 1.
Oh, that's not right. That's universal. That's just.
Yeah, like if it had been something like 2x, then it would be 2 times 1. So usually think of the x sort of just.
Okay.
If it's all by itself, it's.
Yeah. Right. Got it.
That's why that is 4x. And that's
Right. Okay. Much like
Okay. This is not the answer, but this
But
is.
it's like the right concept.
This is the same as that.
Alright, so then just simplify that.
Or you want some
Or like multiply.
Yeah, right. Okay. Yeah, I think it's a little nicer to write this as. This is like 5/7.
3, I got 7 x.
Yes.
What I thought was, once you have, like, pretty much, I thought you needed 7x squared power, so that's 35x negative 2. Okay, wait, so, oh, I don't do them. Yeah.
Oh, that's right. That's what I was thinking.
Oh, yeah.
It was plus, it should be. Doing all right?
Yeah. What time of
So you thought, so this is an denominator, you said you have 5x squared, negative, and then you have 7, and then you have to simplify from there.
I still do it, but.
I mean, I haven't been. I don't think one. I don't think
Yeah, I think so. Maybe I should just break up.
5 is here, 7 is here.
Okay.
What'd you get for number?
Root x is x, so then we're gonna move 1 half down.
Oh, it's
Doing all right?
What'd you get
So when you move this, it's all 7. When you look all over, this is from the
I feel like 2 times
How's it going? That's the first one, sorry. Actually, I have a.
That's my
This x. Of just x becomes 1. So that's just. Yeah, remember square root of x is the same as x to the power 1/2. And then you can handle that like the way you These 4x.
Seems to be. Because it would be the negative 2. There's a lot of things to
Negative 24, x is negative 3.
Yeah, that was my question, because this one is number.
So basically what I did was, well, this is exactly what he brought this up and made it negative, and then, yeah, he brought this up and made it negative, and then he simplified it. So I have 3 plus x times 4 times
like the opposite.
4x negative 2.
But it's negative, this is negative g, so you just add. Yeah, so when I get here, like what, I feel like I'm just kind of going in the wrong direction.
This is good. Now from here, you should do all these steps are just
Negative 2.
Okay.
Here. Oh, that's good.
And then
So
I just
you should
have-
use this
No.
Oh, no.
Wait, so, excuse me. Oh, sorry. When it's like 5 times, I get it, 5, 7,
Yes.
and then negative 2.
Yeah, that's good. Yeah.
Sorry.
What is the, so that should be like this, right?
Yeah.
So when it's like on x, is it like I get the x over 4? Yep. It's just 1 over 4 and x. Okay.
Yeah, I don't know.
So it's just 1. And is it?
And then this is actually good so far, but it never did.
Number 4.
I guess number 4.
That's why I didn't get it.
This isn't working. It's the calculation. It's not working.
I got 1 plus -2. It's 1 over 4.
We're gonna even add.
Is that wrong?
All right, let's talk about these. I see not quite everybody is all the way finished, but that's all right. The first one, this is just a simple derivative of all of this stuff. I get 40x to the 4 plus 21x squared minus 1. I hope that's what everybody got. Remember, x by itself becomes 1. And the plus 3 at the end there goes away because a constant becomes a 0. All right, that was the easy one. Let's try the next one here. So I'm going to just move this stuff down so I have enough room. This guy here, remember, how do you handle the square root? The square root is the same as a 1/2 power. So this is the same as derivative of 3x squared plus 2x to the 1/2 minus 4x. I didn't do the derivative yet. I just rewrote, changed the root x to a x to the 1/2 power. And then I'm going to do the derivative. So this now becomes 6x plus 2 times 1/2 x to the minus 1/2. That was the power rule right here. The 1/2 comes down, and then you decrease the exponent. And then minus 4x becomes minus 4, like so. All right? As I was walking around, I saw a lot of people trying to do, you'll notice, like I wrote out an intermediate step here. A lot of people tried to do this intermediate step sort of in their head, both steps at the same time. That's okay with me if you can handle that, although it's very easy to get confused. In the first step, all I did was rewrite this part because root x is the same as x to the 1/2. And then in the next step, I actually did the derivative. All right? Can I just say one thing? Like I said, if you can do all of that in one step in your head, that's fine with me. Can I say, here's something that you definitely should not do, and I see this every so often. As I was walking around, I saw a couple of people wrote something like this. They say this, actually it's more likely they would say it like this. Okay, this part is 6x, this part is 2x to the 1/2, this part is minus 4x. What's wrong with that? Anybody have any feelings about that? I mean, it's not the same as the true answer, which you see up there. What's the problem? Yeah.
The square root of x is in the derivative.
Yeah, the middle thing, like what I did with these arrows here, I guess, in the first arrow, I took the derivative. In the last arrow, oh, I didn't even do that. I meant to say just 4 here. Here I took the derivative. Here I took the derivative. Here I did not take the derivative. Like this, what you have here is something where you kind of did the derivative on some of them, but not all of them. This is not, these things don't go together. Like, you should not write them all together because you're not done with this piece of it yet. So I think it's a lot clearer if you just rewrite the whole thing first and then take the derivative of the whole thing next. All right, this right here is not, it's certainly not the derivative of that. It's not really anything. So don't do that. All right, let's try this one here. This one you should think of as the derivative of 5/7 x to the minus 2. That's bringing the 2 up. Don't also bring the 7 up unless you make it a 1/7, but then there's no point in bringing it up at all. You might as well just keep it with the 5 because now it's just a coefficient in front of x to the minus 2. And now the derivative, I go minus 2 times 5/7 x to the minus 3. And that's all. I hope that's what you got. Any questions about that one? You could combine those fractions in the front, -10/7. I don't care about that. All right, and these last two are the more complicated ones. These ones involve bringing the denominator up and then distributing. So I am going to first bring the denominator up here. It's 3 plus x, and then when I bring up the denominator, it has to look like 1/4 x to the minus 2. The 1/4 is what happened with the 4. The 4 is in the denominator, so it has to turn into 1/4, and then the x squared in the bottom becomes x to the minus 2. And then I'm going to distribute here and here. We get derivative. So the first distribution, the constants, 3 and 1/4 gives me a 3/4, and then x to the minus 2. And then plus the other one, x and a 1/4 x to the minus 2 is a 1/4 x to the minus 1. That's because we are adding the exponents when you multiply x and x to the minus 2. I hope that's what you got. I'm not done yet because I didn't take the derivative yet. You can tell because I still wrote that thing. Now I'm going to actually do the derivative of all of that, and we get minus 2 comes down times 3/4 x to the minus 3, and then minus 1 comes down 1/4 x to the minus 2. I hope that's what you got. Any thoughts about that? As usual, I don't think it's important to simplify beyond that. Okay, and then finally, the last one here is again similar. We're going to bring the denominator up and then distribute it. So here, bringing the denominator up, and I'm also going to change x, root x to x to the 1/2. But it looks like that when you bring the denominator up. The 2 on the bottom stays like a 1/2, and then the x on the bottom becomes a x to the minus 1. And the rest of what was on the top stays like it was, except I rewrote, root x is the same as x to the 1/2. And now I'm going to distribute the x to the minus 1 and the 1/2. So this is now derivative of 1/2, I believe, just x. That's I'm doing this, this, and this. X squared times 1/2 x to the minus 1. You add the exponents as usual, you get x to the power 1 right here. And then plus x to the 1/2 times 1/2 x to the minus 1 is going to be 1/2 x to the minus 1/2. And then plus 1/2 x to the minus 1. I think I did those correctly. This is what you get when you distribute. And now it's just the derivative of those three things added together, so we just do each derivative separately. Finally, this will be my final answer. 1/2 from the first part, and then it's going to be 1/2, minus 1/2 times 1/2 x to the, what's the new exponent on this one? It's negative 1/2, and then I have to subtract 1 from that. Negative 3/2, somebody said. Yeah, this is a little taxing if you haven't thought about this before, but if you have negative 1/2, subtract 1 from that. That's the same as subtracting 2/2, so minus 1/2 minus another 2/2 makes negative 3/2. And then finally this one, the minus 1 comes down. So this is minus 1 times 1/2 x to the minus 2, like so. And that's how we do it. Any thoughts about that one? I hope you got something like that. Not everybody made it to the last one, but that's how we do it. All right, great. That here ends the discussion of the power rule. Let's move on to the next thing then. Actually, the next 3 topics on the list are other rules. The power rule is the one, the first and the most important one that we did. But there are other rules for other kinds of functions. The power rule works just for a power of x. The power rule is great for powers of x added together, right? But that's really the only situation when you can use the power rule. If you have anything else going on, for instance, things which are not added but are divided, for instance, like this last one here we did. This is 2 things divided by each other. And as I said before, you cannot just take the derivative across the top and also take the derivative across the bottom, because the derivative doesn't work that way. So when you have things, just things added together, everything is fine. But in all other situations, you need to use special rules, which we're going to talk about. And the first of the special rule is how to handle a product. So the power rule is good for powers of x added together, but things in products are more complicated. That is, things which are being multiplied together. Things in products are more complicated, and you need to use a special rule for those things, and it's called the product rule. The product rule, it tells you how to find the derivative when two things are multiplied together, which is not something that you can do just by doing the thing with the powers, all right? The product rule, it's how to find the derivative when two things are multiplied together. And this actually is, it comes up in real life, the derivative of two things multiplied together. This would come up in real life if you want to know how fast something is changing. That's what the derivative is all about. How fast something is changing when the something that you're talking about is actually two things multiplied together. And I don't know if that sounds weird, but you could imagine something like if I have some investments and I want to tell how my investment is changing over time, I would just use the derivative of whatever the investment is. But what if maybe I have an investment which is in some kind of foreign currency, maybe like I'm invested in something with euros. Then when I think about the value of my investment, I have to think about how the actual value of the thing is changing, but also I have to think about how the euro exchange rate is changing, the euro to dollar exchange rate. And you would really have to multiply those two things together to get the sort of true value of my investment in dollars. So that's an example where you have something changing, but what's changing is actually a multiplication of two other things which themselves are changing. You have to figure out how does the one change relate to the thing, to the product of the two other things. All right. So anyway, this is what the product rule is used for. Like, for example, if I asked you to do something like derivative of 8x squared plus 5x plus 1 times 3x to the 4 minus 7. What's the derivative of that? And there's a special rule for this, all right? This is what we're trying to talk about. And I will just say, as I've said several times before, you cannot just take the derivative of this one and also take the derivative of that one. You can do that, but it's not the correct answer. The derivative has a special rule when it comes to products, all right? So can I come back to this example? Because I got to tell you about the product rule and what it is. So the product rule is generally, it's for something like derivative of two different things multiplied together, right? If I want to find the derivative of some first function times some other function, there's two functions in there. How do you find the derivative of their product? All right. Now, because we don't already know the rule, the only thing that you can do to try and get a handle on this is just to use the definition of the derivative, which we almost never want to use, but there's really no alternative in this case. So using the definition, the derivative of f of x times g of x. This, by the definition, of course, I mean the thing with the limit as h goes to 0 of something or other divided by h, that thing, right? I hope you still remember this, you all remembered this on the test last week. The limit as h goes to 0 of, it should say f of x plus h minus f of x divided by h, right? But in this case, it's not just f of x that I'm working with, it's f times g. So if you do this properly, it's going to look like this, f of x plus h times g of x plus h, because the thing I'm doing the derivative of is the product of these two things. It will look like this if you do that correctly. This is the derivative of the product, all right? And it turns out by doing some cute little tricks, you can simplify that thing and come up with a nice, a nicely formed sort of simple rule. So here's my cute tricks for this fraction. I'm going to do the old add and subtract the same thing. So it'll say f of x plus h times g of x plus h. That's just what's on the front there. I'm going to subtract f of x plus h times g of x without the plus h. All right, and then I'm going to add that same thing again. F of x plus h times g of x minus f of x g of x. All right. Why did I do that? It's because I know what's about to happen. Like that this somewhat magical step here causes good stuff to happen in later parts. All right. And then what I'm going to do next, this is This is a little nasty looking, but it's about to get a little simpler. I'm going to separate this big fraction into two parts, one being this part and then the other being this part. So both parts will have h as the denominator, but in the numerator you see like two things added together. We're just going to split it apart into two separate fractions. And would you mind if I did another thing at the same time? The first of these two fractions, look in the numerator, both of these things have f of x plus h on them. So I'm going to factor that out to the front. It will look like f of x plus h times, and then what's left over is g of x plus h minus g of x divided by h. That's the first, sort of the leftmost block of this big fraction. You split the fraction apart into two big blocks, and then from the first block you can see both parts in the numerator have this f of x plus h, and we factored it out. And then the other one, it's going to say plus, and if you look in the second one, both parts of this one have g of x, so I can factor that out. G of x, f of x plus h minus f of x is what's left over on the top, and h on the bottom. All right. This is a little complicated, but actually that was the last weird step. The final step, I'm going to actually do this limit. Take make h 0 everywhere in there. So what happens when I make h 0? This f of x plus h becomes f of x plus 0, which is just f of x, times this fraction. When you make h equals 0 here, that is the derivative of g. That's the definition of the derivative of g, is that stuff. So this actually equals g prime of x plus g of x here is just g of x. And then the last thing, this is the definition of the derivative of f of x. So this is f of x. And here ends the cute tricks. That is a usable formula for the product rule. So this stuff in the middle, I would not suggest that you try too hard to remember, but you should remember the answer. So I'm going to summarize. Where we started, remember, was the derivative of f of x times g of x. And the answer is f of x times g prime of x plus g of x times f prime of x. And this you need to remember. This is called the product rule. This is the formula for how to do the derivative of two things added together, all right? And make sure when you write this down and when you remember it, these primes got to be in the right spot, right? The prime makes a big difference. So this, when it says f of x, that just means the first of these two functions, right? This is just the first function as is. Then g prime of x, that means the derivative of the second function. And then you go plus the second function like it is times the derivative of the first function, all right? This is called the product rule, and you should memorize this. We're going to be using it so often, you know, when you do the next homework assignment. Hopefully you'll use it enough times that you don't have to ever like sit down and consciously memorize it, but it is super important, and we're going to be using it for the rest of the course. Although I will say, when I remember the product rule, I don't actually really think of it in terms of a formula like that. So the way that I think of this is, over here I have two functions here. There's like the first one and the second one, right? And then what I see on the right side is just the first function times derivative of the second. That's this part. The first one times the derivative of the second one. And then plus the second one times derivative of the first one. All right? That's what it says over here. The second function times the derivative of the first function. So actually these words is how I remember the product rule. I don't really think of it in terms of f's and g's. I just say it's the first times the derivative of the second plus the second times the derivative of the first. I find this fairly easy to remember. All right? That's the product rule. And if provided you can remember the formula, it's pretty easy to use. So let me just revisit that thing I said at the very beginning. This one here, right? Can we do this? So this one, derivative of 8x squared plus 5x plus 1 times 3x to the 4 minus 7. So in terms of the f's and the g's, this is my f, that's the first function, and this is my g, the second function, right? And the product rule says the answer is the first thing times the derivative of the second thing plus the second thing times the derivative of the first thing. And you can do all of that more or less in your head. I mean, you got to write down the answer, but what's it going to be? The first thing, so the first thing like it is just the first thing times the derivative of the second thing. The derivative of the g part, that would be 12x cubed, right? So this is the first times, this is derivative of the second, right? I'm trying to do the product rule here. The first thing times the derivative of the second thing, and then plus second thing times the derivative of the first thing. All right, the second thing, just like it is, 3x to the 4 minus 7, times the derivative of the first thing is, look at the first thing and take the derivative, 16x plus 5. So this is the second times derivative of the first. All right, this is how we do the product rule. You just have to remember that. First thing times derivative of the second thing plus second thing times derivative of the first thing. All right, why is that the appropriate rule to use? Like why does this work? First times derivative of the second? It's because of all this nonsense that you didn't really want to hear in the first place. But take my word for it. I mean, that's why it's true, but it is true. You don't have to remember all of that stuff. You do have to remember just how to use it, which is, not so bad provided that you remember it. All right, let's try another one, and then I have some for you to try also. Another derivative of a product. How about, let's just do another sort of simple one here. Derivative of 2x plus 1 times 3x minus 4x squared. All right. You don't have to think too hard about this. Just sort of follow the red words that you see at the top there. You do the first thing like it is, times the derivative of the second thing, and then plus the second thing times the derivative of the first thing. What do I get? The first thing is 2x plus 1 times derivative of the second thing is 3 minus 8x, right? I hope I did that right. This is just the first half of the product rule. That's the first thing times the derivative of the second thing. And then I go plus the second thing like it is, 3x minus 4x squared, times the derivative of the first thing. What's the derivative of the first thing? 2, yeah, just 2. Just 2. That's it. This is how you do the product rule. As usual, you may look at this and say, oh, I could probably simplify that. And I would say, yeah, you could probably simplify that. I don't really care if you do or not, but I would just leave it. I would drop the mic at this point. If your job was to take the derivative, this is the derivative. It may not be simplified all the way, but that's fine. Unless you have some reason to simplify it, I wouldn't go any further than that. All right, how about one more? You can do some fairly big and nasty product rules. How about x to the 4 minus 3x cubed plus 2x minus 7 times 8x to the 4 minus 2x cubed minus 3x squared plus 4. All right? It looks bigger, but I mean, there's nothing to it really. You just have to keep straight the first thing times the derivative of the second thing plus the second thing times the derivative of the first thing. So I go the first thing like it is just like it is. I'm just copying the first thing first, and then times the derivative of the second thing. For that, you just read down this one and take the derivative as you go. So that would be 32x cubed minus 6x squared minus 6x, and the plus 4 goes away. So that's the first thing times the derivative of the second thing, and then I say plus the second thing like it is, 8x to the 4 minus 2x cubed minus 3x squared plus 4 times the derivative of the first thing, which is 4x cubed minus 9x squared plus 2, like that. And this is how we do the product rule. Don't try to simplify that unless you have a reason. All right? Great. This is the product rule. So this is what you use when you're taking the derivative of a product of two things. Would you believe it? There's also a rule for a quotient of two things, and it is called the quotient rule. So can I just tell you the quotient rule rather than going through the derivation? It is another fairly simple formula, although it's, I suppose, slightly more complicated. But this is what you have to do when you take the derivative of a quotient. I should write this in big words up here. This is the quotient rule. It's similar to the product rule, but it's different, and this is the rule you have to use when you take a quotient. You can go through a similar derivation using the definition and doing this add and subtract trick. I don't think it's worth going through that stuff. Again, I will just tell you what the answer is if you don't mind. It is. So I think of this one in terms of the bottom and the top, right? And the answer is the bottom times the derivative of the top minus the top times the derivative of the bottom, all divided by the bottom squared. So this is the quotient rule. And when I do this, when I think of this in my head, I don't actually remember that formula. I remember all those words that I just said to myself. So it is the bottom times derivative of the top minus the top times derivative of the bottom, and then all over the bottom squared. Make sure you have the primes in the right spots in this formula, right? It's important. Okay, so this is the quotient rule, and you use it just the same way as the product rule. Actually, would you mind if I tell you, I have a really stupid way of remembering the quotient rule that sometimes runs through my head. I learned this when I was but a young man. Now I am a grown man, but I still have this running through my head from time to time. If you think of the original thing as high over ho, sometimes people say high over low, but I prefer high over ho. The answer, the quotient rule is ho d high minus high d ho over ho ho. How do you like that? Where d means derivative. This is the stupid way that you can remember the quotient rule. Don't say this out loud in the club, but sometimes when I'm doing the quotient rule, this is what I'm saying to myself in the back of my mind. Any way you want to remember it, as long as you can remember it and do it properly. All right, so let's just do a couple examples like this, and then I have some for you all to try involving products and quotients. So the quotient, let's try, how about x squared plus 3 over 3x minus 1? I will reiterate yet again, you cannot just do the derivative on the top and also do the derivative on the bottom. You will get the wrong answer if you do that. What do you do instead? Well, you do the quotient rule. That's the point of the quotient rule. So it is the bottom times the derivative of the top. I begin with the bottom like it is, and then times the derivative of the top is 2x. Make sure you put parentheses in here because it matters. If you left out, including these parentheses means that you, in theory, if you were going to simplify, you would distribute here. If you leave the parentheses out, it means something different. So you should include the parentheses. Anyway, that was bottom times derivative of the top minus the top times derivative of the bottom. The derivative of the bottom is just 3. And then all of this divided by the bottom squared. And that's what we get. Again, you could probably simplify that if you want to, but I'm not going to expect you to simplify it unless you have some reason to. Let's try just another one. These really don't get any more complicated than that. Let's try the quotient rule here. Again, it's the bottom times derivative of the top first. So the bottom, x squared minus x plus 1, times derivative of the top is 4x cubed, minus the top, x to the 4, times derivative of the bottom. That would be 2x minus 1. All of this divided by the bottom squared. Right? You can probably see by now, you have to be sort of a permanent expert in doing the power rule, because that is involved in every little piece of this. Not every little piece, but certainly some of them. That you need to do sort of by second nature so that you can do the rest of it. This is the quotient rule. Any thoughts about that or questions? I got some for you to try. Let's try some, and then that might do it for us. So take the derivative of each one of these things. How about derivative of x squared plus 1 times 3x to the 4 minus 8x squared plus 2? How about the derivative of this one? See what you think.
Oh, 2 times.
Good? And go to the product rule. The first thing times derivative of the second. Doing good? All right. Looks great. Okay. That's great. There should be a plus. Good. Right there. Got it. Remember? Yeah, that's good. There should be a plus in the right here. That's part of it. How's it going? It's good so far. You're doing the product rule, which is the first thing, and the derivative is the second thing. Because the first, these are two parts. The first part times the derivative of the second part. And the plus the second part times the derivative of the first part. It's doing text instead. All right. Yeah, that's pretty good.
Yeah, it's really
This.
That was negative.
Yeah. Good? That's good. Yeah.
And do any parentheses?
Looks good.
It's like good.
But if it was just a single term, I know, right? Like,
It's swept back up too.
Yeah, the purpose of the parentheses is for every like history of every custody matters here.
I feel for you.
All right. Good. Okay. All right, let's talk about these. Sorry I didn't get over here, but I have one more thing to say before we leave today. So the first one is the product rule. I go the first thing like it is times the derivative of the second thing should be 12x cubed minus 16x, like that. And then plus the second thing like it is times the derivative of the first thing, which is just 2x. And I think that'll do it. I hope that's what you got. Some people ask me about the parentheses. How come I put parentheses around this one but not around this one? It's because parentheses around this one don't really matter. So if you like, you can put parentheses around this one. It doesn't make it wrong. The reason it's not necessary because this is just one thing by itself. It's just a single term. So it doesn't matter if you put parentheses around it. Whereas this one really does. It's two two different terms here, and it will distribute differently depending on if you put the parentheses or not. This one I do the quotient rule, which is the bottom times the derivative of the top. Now the top has this square root in it. You just have to remember that is really the same as x to the 1/2, right? So when I do the derivative of the top, 5x squared becomes 10x plus root x, which is the same as x to the 1/2, becomes 1/2 x to the minus 1/2. So that was the bottom times the derivative of the top, and then I go minus, this is the quotient rule, the top times the derivative of the bottom. Back that up if I can. The top times the derivative of the bottom. So 5x squared plus root x times the derivative of the bottom is 2x minus 2. And all of this divided by the bottom squared. I hope that's what you got. Any questions about that? Yes?
If I put the 5x squared plus like rad x at the front, does that change the answer or not?
If you write, so you should have two things on top that are subtracted, right? If you write them in the opposite order, then what you wrote is the negation of what I wrote. So that is different. So you gotta write it in the correct order. Yep. Yes?
If we in the second part where you're using like the top and you change it to the square root of x to the 1/2 power, is that fine?
Right here?
That way?
Yeah, I wrote root x, but if you wrote x to the 1/2, that's fine.
Okay.
Yeah, those are the same. So, yeah, great. All right, we got 10 minutes, and I want to do one more example, which probably won't take that long, but let's try one more example. That is, sometimes you have to do both at the same time, the product rule and the quotient rule. So they can be combined. This is not too hard, although it can be very confusing. You have to sort of keep your mind on straight, if you will. They can be combined. I mean something like, let's just do one of these. How about this? So this is, it is both a product and also a quotient. So what are you going to do? Are you going to do the product rule or the quotient rule? Well, you're going to do both, although you have to think about exactly how that is going to work out. I would say when I look at this overall, it is overall a fraction of two things, right? And it just so happens that the thing on top is also a product. Okay, so if I were to describe the structure of this thing, I would say it's a quotient and the top is a product. All right, that's how I think of this. And what that means is I'm going to use the quotient rule because it is a quotient. And at some point during the quotient rule, you have to do the derivative of the top. And when that moment comes, we use the product rule to take the derivative of the top. All right, so I'm going to use the QR, the quotient rule, but when taking derivative of the top, you use the product rule, PR. All right. Overall, it's a quotient rule, but at some point during the quotient rule, you have to take the derivative on the top, and in that step, we use the product rule. Okay, so it looks kind of big and nasty, but it is. So like I said, overall, we're doing the quotient rule. So I'm going to do the bottom times the derivative of the top to begin with. So it's the bottom here times the derivative of the top. And right here, the derivative of the top, maybe I'll put it in these gnarly brackets. The derivative of the top involves the product rule because the top is a product. And so when I do the derivative of the top, it's the first thing times the derivative of the second thing plus the second thing times the derivative of the first thing. That looks like the first thing times the derivative of the second thing, 6x plus 2, plus the second thing, I need more space in my brackets here, 3x squared plus 2x times the derivative of the first thing. I fit it in. The derivative of the first thing is 1. All right? So what you see here is the bottom. What you see, all of this is derivative of the top. All right? And that thing there is so complicated because the top was a product, so I had to use the product rule to do the derivative of the top. Are we done yet? No, because I'm doing the quotient rule here, and this is only the first bit of the quotient rule, right? The full quotient rule is the bottom times derivative of the top. That's what I did, and then minus. The rest of it is easy though. Minus the top times derivative of the bottom. Okay, the top is this product stuff, but I'm just doing the top as is, times derivative of the bottom, which is 4x minus 1. So this over here, this is the top. This is derivative of the bottom. And then to finish the quotient rule, all over the bottom squared. Like that. Complicated and confusing, but if you think it through straight, it's not so bad in my opinion. All right, you will have some more practice of these on the homework, but that's the product and the quotient rule. So we will have a homework assignment due on Tuesday. I hope you all have a good weekend. And please let me know if you want to talk about the test. I would be happy to sit down with anybody and go over it. See you next time.